Hello everyone. Let's get started with Unit 1, Basic Fishing. I've always thought that a good place to start when learning about fishing is actually with the fish. So that's what we're going to talk about in this lesson. First, I'd like to direct your attention to this illustration by Larry Topol. He has been a wildlife illustrator, photographer, painter for, 40 years or so. And I have ripped off many of his slides from the internet and posted them throughout this class just for your appreciation. If you've read any outdoor life, field and stream magazines over the years, I'm sure you've come across his illustrations. He's credited with being the man who has spent most time underwater filming and photographing freshwater fish. So his illustrations are incredibly realistic, incredibly accurate. I hope you appreciate them as they come by. So let's go ahead and get started. This is a largemouth bass and a very typical freshwater species. In fact, one of the most popular freshwater species. And if we look at the anatomy of the largemouth, the first thing we notice up here are the dorsal fins. And largemouth bass are a little unique in which they have both a hard dorsal fin, that's these spines sticking up right here. They're actually quite hard. And then the soft dorsal fin back here. This is more feathery. You can like bend it over. It's just a unique characteristic of the largemouth bass. What's the purpose of a dorsal fin up here? Well, it's vertical stabilization. Think of it kind of as the vertical stabilizer on an aircraft. It keeps the fish vertical. It doesn't allow it to flop over one way or the other. If we come right back here, we've got the caudal fin. You could use tail fin if it ever should happen to show up on a test or quiz or anything like that. The caudal fin's purpose is just pure locomotion. This is how the fish moves through the water. Fish really only have a forward motion. They don't have a reverse gear, so to speak. So this is for forward propulsion. And if we continue right along, we get to the anal fin. And again, this is a soft fin. These spines are pretty pliable. Again, the purpose of the anal fin in conjunction with the dorsal fin is vertical stabilization. And if we move forward underneath, we come to the pelvic fin right here. These are maneuvering fins. This allows the fish to fine-tune its maneuvering whenever it's coming in to eat something. I have watched bluegill come up and inspect a fly using the pectoral fin and the pelvic fin. I have watched bluegill literally do a 360 around the fly, inspecting it before they take it. This just allows very, very fine maneuvering control for the fish. This is the pelvic down here, and if you think about it, we have a pelvic girdle, and it is below our pectoral muscles, which are up on the chest. So just if you keep that in mind, I don't think you'll get those confused. Of course, over here we have the gill cover. We have an eye, the mouth, and the last thing up here is the lateral line. The lateral line we're going to talk about more in just a few minutes, but it's a sensory organ that allows the fish to locate food. Don't confuse the lateral line with these scale stripings right down here. They're not always the same. on all fish. So, the last thing I'd like to point out is something we can't see in this illustration, but that's the mucus layer. The mucus layer is literally that. It's slime on the fish. If you've caught a fish, you've experienced the mucus layer. Its purpose is to protect the fish from parasites. It's kind of the force field for the fish. There's a lot of parasites that can get into a fish. If anyone who's ever kept aquarium fish may have come across the dreaded condition called ick, which is short for a great big long scientific medical term that I can't even begin to pronounce. But ick is a parasite that gets into aquariums, and it attacks a fish, and basically it turns them white and in this fungal growth. And it's gross, and it kills the fish, and then you have a screaming 4-year-old daughter, wondering why Thumper's not moving and swimming around in the tank. Internally, we can take a look at the fish and see what similarities we share with them and what differences we have. We can see all the fins that we've just talked about, the dorsal fin, the tail fin, the anal fin, and the pelvic fin. We've got a brain up here, quite small for fish, spinal cord, muscle groups throughout the body. Internal organs, consist of what we would expect, kidney, ovaries, stomach, esophagus, heart, no lungs. Yeah, that's something that is much different in fish. Instead, they have the gills, and they really function very similar to our lungs. Our lungs are contained in our body. They're made up of think of them almost as bushes. In our body, and at the end of these bushes are little buds that allow for the transfer of oxygen between the air and the bloodstream. The gills are functioning exactly the same way, except being contained inside of our body. These gills are kind of exposed, almost to the elements in the water, so that the water can pass over those alveoli and make that exchange between the oxygen and the blood. The other thing you may have noticed on here is a swim bladder, and anyone who has caught a fish and cleaned a fish has probably seen the swim bladder. And okay, yeah, if you're a 5-year-old kid, you're playing with the swim bladder. I know you're doing that. The swim bladder allows the fish to control its depth. It can come up to the surface by deflating the swim bladder or inflating the swim bladder, and it can descend into the depths by deflating the swim bladder. The swim bladder changes the buoyancy of the fish. The sensory organ that we talked about just a few moments ago, the lateral line, this is an internal organ. You can, on some species, see indications of where it is. On largemouth bass, it's up above the scale stripe. This is a mucus-filled organ. It's an organ, just like what we talked about, and it has thousands of little nerve cells in it, and these nerve cells can detect vibration. And if a fish is swimming about and it picks up a disturbance from some distance away, it can start to fine-tune the exact location of that disturbance using the lateral line. The long-range sensor of a fish, so to speak, is the ear, which is located right up in here. The ear functions kind of similarly to the human ear in that it detects variations of pressure. That's the long-range sensor. The near-range sensor is the lateral line. This is what allows a fish to eat. It can pick up a thrashing, a bubbles, some type of disturbance using the ear from long distance, swim in that general direction, but the fish is going to start using the lateral line to really fine tune where that's coming. Since the lateral line is on both sides of the fish, it can simply turn from one side to the other, kind of like what we do with our hearing, our ears, and detect range and bearing, and then zero in on its next meal. If you're out in a metal boat and you drop a hard-bodied lure into the bottom of the boat and it clanks, you've just told every fish in the lake exactly where you are. If you're fishing from shore and there's gravel on the shoreline and you're crunching through that with each step, you're telling the fish in the stream exactly, or the lake, exactly where you are. The sound travels through the ground and out into the water. If you're walking a trail along a stream and you're tripping over sticks and rocks and kind of stumbling and you're heavy-footed, you're telling the fish exactly where you are. So one principle in consider while you're fishing is that change the verb from fishing to hunting, because in essence that's what we're going to do, is we're going to hunt for fish.
Captain, long-range sensors are picking up transwarp signatures. 5.8 light years distant, closing from behind. Red alert.
Fish can see not terribly well, and the comfort of the fish has a lot to do with sunlight. And fish don't have eyelids. Fish also can't dilate or constrict their pupils. So this is totally unlike we humans. On a really bright sunny day, we can use our eyelids and squint to cut down on the amount of light, and our pupils are constricting, getting much smaller to reduce the amount of light coming into the eye so that we're more comfortable. And it also protects the eye. In dark conditions, that pupil dilates and gets really big so that it can gather in more light so that we can see a little better in the dark. Fish can't do this. The only way that they can control the amount of light coming into their eyes is by either seeking shade, like under a boat dock, an anchored boat, a tree that has fallen in the water, someplace where it can get up and under something in the shade to shield its eyes from the direct rays of the sun, or it can go deep. As it goes deeper into the water column starts to absorb the energy of the sun, and it gets much more comfortable for fish. So that's something that we'll talk about more, I think, in Unit 3, about how sunlight really affects fish and how we can use that to help determine where fish may be.